Good afternoon and welcome to our webinar dedicated to Pyramis. I'm Cristina Fumagalli from Chin System Marketing Team. Today I want to introduce you my colleague Luca Trevisan.
Hello, good afternoon to all of you and thanks to be with us. I will be speaking about our software Pyramis, software dedicated to 3D printing, and welcome everybody. All the questions, please, I will answer at the end of the webinar. So let's start with our introduction. So Pyramis is a software dedicated for 3D printing. Our software can basically manage DLP or LCD technology, so technology based on image, and can also manage laser technology, so SLS or SLM, so with polymers or with metal. Cannot manage FDM technology, so no wire deposition technology. This is how the software looks like when you first open it. So it works in this way. On the right side of the screen, there are few icons dedicated to the workflow. So from the start of the workflow until the execution of the output file. On the left side, there are few icons dedicated to instruments, tools, and other things. Okay, let's start with some sample of the workflow. Okay, we start here by creating a new job. Here we can define the name of the project that we are creating, or by default, the software assign project name with the data and the hour of the current job. Then you can select from different machine. Software can manage multiple machines, of course. So we select one machine. Software can manage, as I was saying, DLP technologies or laser technologies. So if we select a DLP machine, then we can select from a list of resin already available with the software. If we select a laser machine, then you can select from different laser etching profiles. So basically different profiles dedicated to different powders or different methods of etching. Here, once we have selected the machine and the resin that we want to use, we jump to the next step. Next step is the file importation. So here we can select the files that we want to import. So basically we work mostly with STL, but it's possible also to import other file formats. Once we select one file, we have here a fast preview of the file that we are importing. And if we click on the file, we can get a dynamic preview of the file where it's possible to move and to rotate the object in order to better understand the object that we are importing. There are also different options during importation. So there is the possibility, especially for dental market, to flip objects. Imagine to this crown, most of us know that this part must be printed upside down. So in case we want to import this crown, we must enable this option. Or there is the possibility to maintain original coordinates of the STL, or to scale or to assign different supporting profiles directly to the STL that we are importing. We can also, for example, import multiple objects at the same time, just by selecting them multiple times on the Explorer window here. So I now import a couple of files. I click on this button and select. Okay, as you can see, I just imported these files upside down. So in the preview files is in this direction. imported is rotated upside down because I've enabled this command. Okay, let me import one more file. Okay, here it is. Once I imported my files, I can in every time select a single file or multiple files and move them freely into my platform space, or I can just select one file and rotate it or move it along one specific direction. If I want, for example, I can also place my view from top view and then select one single file and rotate the file with the angulation that I desire. Well, once we imported all the files that we want to work with, we jump to the next step. Next step is the nesting. So here we just click on automatic nesting and the software will automatically place all the objects on the platform with specific parameters of distance from border and distance from each object, like in this way. There is another important thing that I can show you. If, for example, we import a file that has some mesh problem, a warning message will be shown. As you can see, there are problems in object. Please use mesh fixer. Okay, what does this mean? This means that, for example, this file has some problem on the mesh. Okay, some problem can be, for example, some disjointed mesh, some hole in the mesh, or something, some mesh that is not completely closed. In this way, the software shows in red the part that the software recognizes as problems in the mesh. So what we can do now? Well, first of all, we can, for example, analyze the mesh of the file to see what kind of problem it is. By clicking one button on the keyboard, you can see this view wireframe, and you can see here, for example, how this mesh is not completely closed. So in order to fix this file, we can just select the file. Once you select one file, a contextual menu will show up. Okay, here in the second tab of this contextual menu, there is some instrument relating to the mesh analysis. Here there is the possibility, for example, to split mesh in case, for example, you have multiple objects on one single STL file, or to join in case you have disjointed mesh, flip or fix normals, or the best choice is always to perform this command, mesh fix. Once you click on this mesh fix, the software will completely analyze the file in order to, for example, close hole or fix mesh problems in any way they can be. Okay, now, as you can see, the mesh is fixed. If we select the object and we analyze it again, we can see how the software has fixed the mesh, and now the mesh is completely watertight, completely closed. In this way, you can print it without any kind of problem. Okay, now again, nesting, automatic. So the software will nest again all the objects in the platform. And here it is. Now, next step is the support generation. So here we can generate supports. Our software can generate supports in two different methods. We call these methods structured or geometric. So basically it works in this way. Structured supports are computed considering starting from minimum points. Then the software is able to analyze the file considering his weight and how much every single support is sustaining. So if I select this option and then I click on this button, the software is now generating supports starting from minimum points and then generating the other necessary points. Other points are considered by considering, for example, overhang values and angulation of the mesh. So we can set different thresholds to let the software distribute supports along the mesh in a specific, in different specific conditions. For example, if I click on this one and select a different support profile, this other method, geometric, it basically created a different way of generation of supports. So it placed the supports starting from the minimum points, and then it generates a grid of supports by using a density parameter that can be set into the configurations. So it's a bit different than the structured support method. If you think that you need some more support, for example, you can add manually supports. So by clicking that button, here you can slice your object to see if you want to add some single support in other positions. Okay, for example, if I want to add other supports in other positions, you can just click on the mesh where you want to place your other supports. Once you're done, you just close it. You can, in every moment, click on one single support, move it, or just modify its dimensions instantly. Or you can select a bunch of supports. So once you have selected them, you can modify the dimensions directly to all of them that you have selected. For convenience, if you create a selection from left to right, you select only the objects. If you create a selection from right to left, you select only the supports. Then, depending on the technology that you're using to print, for example, speaking about DLP or LCD technology, most of the times you need some base support. Okay, so you have the possibility to add a base for every object that you are creating. So by selecting the object, or by selecting all of them, you can enter the contextual menu to the tab of the base and add a base. So now a base is created, and there are different parameters related to the base. So for example, you can modify the thickness of the base, or you can modify, for example, the offset of the base. So the offset is calculated considering the projection of the object on the platform. So in this case, it's a bit more because there is the chamfer here. But if you increase this value, okay, you can see that all the bases are increased. Then you have the possibility, for example, to enable or not these chamfer walls. This will simplify the removal of the objects from the platform when the print is finished. And then you can also add a label. So you can add a label, and in case it's also possible to modify the text of the label. Label can also be placed vertically in case. So it's also possible to save some space in some case in order to print the label. Then, once we have completed our supporting, we jump to the next step. Next step is basically the slicing. So here we have all our data related to this project. So the machine, the name of the project, and the resin that we have selected. So then, depending on the resin that we have selected, we can select from different printing profiles. This depends on how many printing profiles are defined into the configuration. So for example, for this resin, we have set 3 different profiles, one that is able to print at 100 microns, one that is able to print at 50 microns, and one that is able to print at 25. So by selecting each printing profiles, you can see here also dedicated parameters: exposition time, layer thickness, number of bottom layers, transition layers, and so on. By selecting another profile, it's possible to see all the parameters dedicated to the profiles that you have selected. Once you have selected the printing profile, we jump directly to the creation of the output. So here you can see an estimation time for the creation of these objects. This is the name of the output file. You can change the name of this output file anytime you want. And here we generate the output file. Here, at the end of the computation, there is the possibility to see a kind of simulation, a preview of the output file. So if we click yes here, we can see the preview of each single slide. So by clicking on this slide on the right side of the screen, you can go across all the slices. And you can see exactly how the object will grow up. By enabling the 3D view, it is also possible to see the preview in 3D way. So in this way, you have the possibility to better understand what you are looking at. Now let's make an example with a laser machine. So let me create a new job, without importing new objects, but just selecting a different machine. Laser demo. Okay, now this one is a smaller platform. So what I have to do is to select all my objects and put them inside my working area. As you have seen, if my objects are outside of the platform, they became red, just to a visual warning that you are placing something outside of the platform. This area, this yellow area, basically define an area of the working platform near to the border where usually is not suggested to print because you can have, I don't know, some distortion or some bad result. If you, for example, take an object and cross another, you get another visual warning that tells you that the objects are crossing each other. In every moment, you can undo all your operations. Now, let me select all my objects. I want to remove the base. I want to use a different support profile to support all these objects. Here it is. And now we create the output file dedicated to the laser machine. What I want to show you is the simulation of the laser path. It takes a few moments, so we are in real time. Here it is. Here we can see the simulation of a laser path. So by starting from the supports, so you can see here this green line is basically the laser path dedicated to the support. In this case, the support is hollow inside, so it's just a line that defines the contour of the support. And here we can see how the laser path is working. So as you can see, there are different colors of each laser path because we can define different areas for every layer. For example, for external, we consider them bottom layers or bottom skin or up skin. So depending on the part of the object, we can make an analysis of the object between is a kind of intersection between layers to define a part of the object that we want to consider bottom skin or up skin in order to assign to this specific path different parameters, for example, different power or different speed, in order to obtain, for example, different surface finishing. So you can see here that every single layer has a different definition of the areas. Okay, you can see better in some other conditions. Here, for example, there is an area that is growing with another color. This stands for upskin, so it means that in few layers, a cavity will start to begin. Okay, like this. So basically, is an intersection between every layer. We can define the number of the layers to consider for the intersection, and by doing this, it's possible to define different parameters for different areas. Well, now let me show you briefly the possible configurations and the possible tools available in the software. So here on the left, there are few icons. So the first icon is dedicated to the views. Second icon is dedicated to the management of the project. So here you can start a new project, the same as on top right, open an existing project or save the project. So here we have the recent saved project where you can also have a preview, or you can open from a folder a list of existing projects. Then there are, of course, undo and redo buttons. And here is the access to the configurations. So in the configurations, you can see there are different options available. So in the first tab here, there is the possibility to configure the machine. Here you can set, configure, add a new machine, configure it, define if the machine is a laser machine or is a LCD or DLP machine, define the platform dimension. If we select a DLP machine, there are more options. For example, the possibility to define dimensions, the position, the relative position of the zero coordinate into the platform. So the texture dimensions of the light projection. And here there is some option to, let's say, fix some distortion of the image projected on the platform. So in case, for example, that the projector is not well aligned to the, let's say, to the printing platform, is there the possibility to compensate by using these fields? Here is something related to the communication between the machine and the software. And here there is the configuration of the output. Then in the second tab, there is possibility to define different nesting profiles. So for each nesting profile, you can basically define distance from border, distance from object, and if you want to use a fixed height of importation. So you can basically set as many profiles as you want. So for each profile, you can define name and different parameters. In the third tab, there is the possibility to set the supporting profiles. So here you can define different profiles for the supportation of the objects. So the first selection that you do here is between structured supports or geometric supports. So if you have structured supports, you have to set the overhang values. If you use geometric, you can see that these options are no more available because you just use some plane density and automatically set the minimum points density. Then here there is the possibility to define the dimensions of the supports and also dimension related, depending of course on the support. If we speak about a minimum point support or a support dedicated to an overhang area, to a plane, or to a minimum edge. So for each kind of different support or different location where the support will be placed, we can have different dimensions of the support. And here you can set parameters dedicated to the base. So we can automatically let the software create the base once we import the file. So if we enable this one to the dedicated profile, the software automatically will create the base to the object once I import it. Here, in the next tab, you can set the resins. So you can set as many resins as you want. And for each resin, you can set different resins profiles. So for one resin, you can set, for example, in this case, I set 3 profiles. For another one, I just set 2. And of course, in order to set these, you must have the knowledge or the information from the manufacturer of the resins for the exposition times and all the suggested parameters. But in any case, it's possible to do that also by trying and by making some tests directly on your machine. Here you can set the scale in case you want to compensate, for example, the retraction of the resin. This is a scale in X, Y, and Z, and this is an offset to the offset. So basically it works just in X and Y. Subpixel sampling is basically just a kind of anti-aliasing. Time correction factor is the possibility to correct the estimation time that you have at the end of the slicing process. Here there are some parameters dedicated to the bottom layer, so number of the layers, speed, thickness, and exposition times. Possibility to set different transition layers, and possibility here to define the general layers behavior, so the thickness, the exposition time, and so on. There is also an advanced method that provides many other options. For example, possibility to set external contour exposition time, internal, Z compensation, support timing, base timing. So all of these advanced, let's say, parameters. Next up is dedicated to the laser machines. So here you can set different laser etching profiles. So laser etching can also mean different powder profiles. So depending on the powder, you can set dedicated profiles. So what you can set here is basically some basic parameter like layer rate, number of contours for the supports, if you want or not the supports to be etched or to be hollow inside. Then the possibility to enable the top and bottom etching, as I was saying, the up skin and down skin. Here, the number of layers to be considered for bottom etching and top etching. And here, the infill type. So we can define between different infill type. We can define to be square, as you can see here in the preview, or in stripes. Stripes basically is like lines, but is scanned in lines. So basically is defined in lines one after another, or basically line. You can define this for every part of the etching. So for the main, for the top, and for the bottom fill. Then here is possible to define a shift range. So what we do is basically define a range where from one layer to the next one, the complete path will be shifted into a randomic value. Okay, this can be very useful, for example, to have don't have the same path between one layer and the next one, especially for SLM technology, laser metal, to avoid, I don't know, to avoid tensions on the metal at the end of the sintering process and so on. Here is just the dimensions of the preview box, so nothing special. And here the possibility to define the gas flow direction. So the gas flow direction is mostly used on SLM machines. So SLM machines, most of, I would say also all the SLM machines has a gas flow inside. Can be, of course, different gas depending on if the machine is dedicated to titanium or to other metals, not flammable metals. And here you set basically the direction of the gas flow. And depending on this gas flow, we make sure that the scanning direction of the vectors of the laser path will never be at the same direction of the gas flow. This is to avoid that the oxide generated by the welded line will be transported on a part of the object that is not yet welded. Okay, that will ruin the final result of the complete welding process. Last step is dedicated to some general settings. So the directories, where to save projects or import objects or export output files. And this is more or less all about the software. In case there is another possibility that I didn't mention before. There is the possibility, for example, to export a complete platform in STL. For example, there is some machine that use encrypted outputs, so we don't have the possibility to generate output directly to send to the machine. And in some case, some customer wants to export the STL of the platform already with the object already placed and already supported to import directly on the slicer available on his machine. So in this case, the specific machine can have this more button to export STL. So we just click on this button and we have the possibility to export an STL file. Export done. So we can go here, open the output path, and we can see the STL that we have just generated, that has the same coordinates that are in the software, maintain the same coordinates, and has all the supports inside. Well, I think that this concludes the basic workflow and explanation of the software. In case you have some question, please feel free to make it.
Okay, in the meantime, we can remember you that you can see this webinar and the other webinars on our YouTube channel, Team System Dental.
Okay, in case if you have any questions relating to this software or some specific question, you can write it to this email that you can see in the screen, training@simsystem.com. And okay, here are our worldwide contacts. Thank you, everybody, and thank you for your participation to this webinar. And I hope this was helpful for you. Thank you very much.